All right, I'm back. We are on page 254, and this page is like very conceptual, so there's not a lot for us to do, so we're going to just talk our way through it. So far, almost every problem that we've done, although we've had to resort to using equations at certain points, they've all been based on graphs. That's not really the case. Like most limits are actually based on a function definition, and to make it interesting, it's usually based on a piecewise function definition. So what's going to happen is you'll be given the definition and you just have to work with it. So the concept of being to the left of something or the right of something becomes very important, but it always just means on the number line. And you can always figure that out by just thinking like, I need x to be less than 5. So pick a number. 4. Is 4 less than 5? Yes. So you approach from the same direction as 4. That kind of thing. So here's an example of where we would need an equation. So don't look at the equation yet. Just look at the graph. This graph is evil as far as finding limits goes, right? The only interesting limit would be at 3, at x equals 3. So let me just throw in some highlighter here or something, right? So this is interesting because that's a weird thing. The problem is if you look along each of these branches, I'm gonna make my highlighter a little bit smaller, maybe only a little. We'll see if this works. Look along this branch of our piecewise function. Do you see a single lattice point that this goes through? There's not one. It never goes through a lattice point. It's kind of mind-boggling that you can even have a line that never does, but you can, and this is one of them. So let me make a remark here. Okay, let's not use a highlighter to do it. Let me make a remark here. There are no lattice points. And lattice points, you sort of intuitively know, are like the good points. So they're the points where the horizontal grid and vertical grid lines come together. And so for example, like this would be a lattice point. This line doesn't go through any of them, and it means that like we can't really figure out the slope. And if we can't figure out the slope and we don't have a good point that it goes through, how are we going to evaluate the limit, right? If you had to guess, I don't know, it's probably negative 13. Like knowing how this problem is going to go, it's probably negative 13, but we don't know. It could be negative 12.9, it could be negative 13.125. Like there's no way to know. And then we have the exact same problem over here. So this also doesn't go through any lattice points, and so it's a disaster. So this is where you need equations. So the equation for this would have to be piecewise, and it's over here on the side. And so you can see that f of x is actually 2 minus 5x when x is less than or equal to 3, and 4x plus 2 when x is greater than 3. So we can use these definitions to find our limits. And if you think about it, so if I said y equals 2 minus 5x, and I said, what's the logical y value at any x value? You probably wouldn't hesitate. You'd be like, just plug it in. Like, why would I do anything other than plug it in? I always get the logical value. It's a line. And that's exactly what we're going to do. We're going to take advantage of the fact that these are continuous to evaluate. So where can I do this? If I'm going to find the limit as x approaches 3 from the left, so 3 from the left is, you can think of it on a number line if you need to. So here's 3, and I want to approach 3 from the left. So I got to go this way, right? And as I go that way, I need the definition that applies. The definition applying there is this one, because that's where x is less than or equal to 3. So to find this particular limit, I'm going to say that the limit as x approaches 3 from the left of f of x, so you always write this out, equals the limit as x approaches 3 from the left of, what's the branch? It's 2 minus 5x. And then 2 minus 5x we know is a perfectly behaved function. It's continuous, which means at every single point, the limit exists, the function exists, and the limit equals the value of the function. So this will be 2 minus 15, so negative 13, which is what I thought it was, but without the equation, there was no way to know. And then we go back and we do it again. So now what we want to do is we want to approach 3 but from the right. And to approach 3 from the right, we have to use the definition that applies when x is bigger than 3. So if you're bigger than 3, you're going to use this part of the definition. We don't even look at the other part. No one cares what it is right now. All we care about is the part when x is greater than 3, because that's how we're going to approach. So here, I would say the limit as x approaches 3 from the right of f of x. So you're trying to explain to people what you're doing. That's why you write this part. And then what you're actually doing is this, of 4x plus 2. And then that would be 12 plus 2, so 14. So we were able to find the two limits, but we could not do it graphically. Graphically, it's a nightmare because you just have to guess, and there's no way to know. Things that look like 14 could be like 13.9, 14.01, like who knows? But once you have the equations, you definitely know. And not only that, we just proved that the limit doesn't exist. So for this particular problem, since the limit as x approaches 3 of f of x does not exist, there is no logical y value. If the limit existed, the logical y value would be the limit, because why would it not be? Why, when you move from left to right and from right to left, would you get to a certain point, but when you get to that point, it not be the value? There's no logical y value here. All right, and then there's this other additional thing here. If we are able to say this, what must be true? Well, if this is true, it implies that 1, the limit as x approaches c from the left of f of x. I don't like how I put double parentheses around that. Like I got parentheses, f of x, and then there's those parentheses. They're like unnecessary. But the limit from the left must be L. And 2, the limit as x approaches c from the right of f of x must be L. The one thing to keep in mind is that, let's use a different color here. We have no clue. That says clue. That's not very clear. No clue about f of c. We just don't know. Maybe it exists, maybe it doesn't exist. Maybe it exists and it's equal to L. Maybe it exists and it's equal to something else. We have no idea. Limits don't tell you values of functions. That's one, it's hard to get that into your head, but you gotta remember that. A limit is not telling you the value of the function. All right, we're done with this page, so I'm gonna cut this here, and I'll be back in the next video.